Well, hey everybody, Mr. Reeves back with you, and today in this video we're going to be looking at solving one-step inequalities. I'm in lesson 7.1 in the Math 7 textbook HMH. So just a reminder, an inequality is when we compare two values that are not equal to each other. So again, we have the symbol, that one, which means is greater than, right? The larger number comes first. We've got this one right here, which means is less than. And then, okay, if we put the line underneath it like that, right, or that adds the or equal to. Or equal to. Should have left myself more space here. So this is greater than or equal to. This one is less than or equal to. We also talked about the fact that that one means is not equal to. All right, so we spent a whole nother video where we went over what inequalities were. We talked about how to graph inequalities. So if you haven't seen that video, go back and watch that one before you watch this one. All right, but now we're going to actually be solving, all right? So let's talk first about solving inequalities involving addition and subtraction. Remember, when we solved before an equation, we used inverse operations. So the inverse of addition is subtraction, and the inverse of subtraction is addition. And what these properties say is you can do it to both sides of an inequality, and that inequality will stay true. All right, so just a reminder, if we had the equation x plus 5 was equal to negative 12. Well, the inverse of adding is subtracting. We would subtract both sides, and we would subtract 5 from both sides, and we would get x is equal to negative 17. That was the one value that made both sides equivalent. Negative 17 plus 5 is negative 12. So that proves that negative 17 is the only value that makes it true. But now we don't have an equals, we have a less than. We're still going to do the same thing. We still subtract 5 from both sides. Not quite sure why they wrote it like that. Really what we should just have is x is less than negative 17. But you'll notice now, instead of just having one solution, we have infinitely many solutions. And again, in our previous lesson, we talked about how to graph this. We put an open circle on negative 17 because it's not included, and then we go ahead and we shade all of the values to the left because those are the places where x is smaller than negative 17. Over here they're bigger, right? Over here they're smaller, and right there it's equal, but we don't want it equal because it doesn't have that little line on it. All right, so if the inequality involves subtraction, we're going to add, and if the inequality involves addition, we're going to subtract. All right, so let's go ahead and do a couple examples right here. All right, we've got y minus 5 is greater than or equal to negative 7. Well, what is the inverse of subtracting 5? It is adding 5. So I'm going to go ahead and add 5 to both sides, and when I do that, I get y is greater than or equal to negative 2. All right? So now I want to graph that solution. Now notice this time we have the equals. So when I go to negative 2, I'm going to make that circle, but I'm going to go ahead and fill it in. So that's where y is equal to negative 2, but I also want to look at the values that are greater. And remember, greater values go to the right. So there we go. So that is my solution and my graph for that inequality. All right. This time we've got 12 being added to x, so it says 21 is greater than 12 plus x. You know what? I really don't like having the variable on the right side, so I'm going to go ahead and rewrite this. Anytime the variable's on the right side, I'm going to flip the whole thing around, and I'm going to make it x plus 12 is less than 21. Do you see how I just flipped the whole thing? I rotated the whole thing around. So instead of 21 is greater than 12 plus x, now I have x plus 12 is less than 21. If you have the variable on the left-hand side, your life's going to be a lot easier. So then what am I going to do? I'm going to go ahead and subtract 12. And when I do that, I get x is less than, well, 21 minus 12 is 9. So there's my solution. So I'm going to go down here to the number line. I'm going to go to 9. I'm going to put an open circle, but you'll notice it's not an equal to. So I'm not going to color it in. And where are all the values less than 9? To the left. All right. Just real quick, if you had not changed it, if you had simply done it this way, if you had subtracted 12, which you could certainly do, then you would get the relationship that says 9 is greater than x. The reason I like it this way is because this tends to confuse students because they see greater and they think it has to go to the right. But if you read the statement, it says 9 is bigger than all the x values. And remember, the part that you graph, the part that you shade, that represents x. All right, so 9 is bigger than all the x's. But my recommendation to you is when that variable is on the right, just rotate the whole thing around. All right, so that way your greater thans will go to the right and your less thans will go to the left. All right, what about if we have an inequality that involves, I guess it's down here, let's see here, inequalities that involve multiplication or division? Well, once again, we're going to use inverse operations, right? The inverse or the opposite of multiplying is dividing, and the inverse of dividing is multiplying. All right, but however, there's a big difference. Something's going to happen. When you multiply or divide by a negative, you must reverse the inequality symbol. Or sometimes we say flip the inequality symbol. You must reverse it or flip it, which means if it was less than, it must become greater. All right, if it was greater, it must become less than. Less than or equal to, of course, will flip to greater than or equal to, and greater than or equal to will flip to less than or equal to. The reason for that, I went over in a different video. I encourage you to watch the video I made on why we must reverse or flip the inequality sign when we multiply or divide by a negative. But for now, I'm just going to let you know that it is true. All right? So you'll notice we have an inequality here that says y divided by 3 is greater than or equal to 5. So just a reminder again, let's look at the equation. Y divided by 3 is equal to 5. Well, what is the inverse of dividing by 3? It's multiplying by 3. So if it were an equation, the answer I would get was y is equal to 15, right? And that would be the answer right there. Y is equal to 15. But it doesn't just say y is equal. It says greater than or equal to. So now I need those greater than values, which are going to go to the right. Okay, so as an equation, we just get the dot. As an inequality, we get the dot or the point and shading to the right because it is greater. All right, now this one right here, negative 4x is greater than 52. Again, if it were an equation, we would divide both sides by negative 4. All right, and 52 divided by negative 4. Let's see here. All right, 4 goes into 5. 1, by the way, positive divided by negative is a negative. 4 goes into 5 one time, and then we get 12, 13. All right, so if it were an equation, we would just get x is equal to negative 13, and it would be right there, and we'd put a dot, right? But it's not an equation, it's an inequality. And you'll notice in solving that inequality, what did we have to do? We divided by a negative. So therefore, we must reverse the inequality sign. See how it was less than right here? All right, I'm sorry. See how it was greater than? Then it becomes less than. Sorry, it switched. That threw me off. Right there, they switched it. So when they divided by negative 4, they switched it. So the solutions are actually to the left. Even though it started off with greater, and you're going to think greater than goes to the right, the solutions go to the left. So again, open circle. The reason why it's an open circle is because it's not included. And then we're going to go to the left because now it says less than. And by the way, we could check it. What's going to happen is if you pick one of these values over here, like -4 times -8, well, negative times a negative is a positive. I get 32. Is 32 greater than 52? The answer is no. So this one was not a solution. So that means that the shading had to go the other direction. Okay, so the big difference now is when we're solving these problems, if we multiply or divide by a negative, we're going to have to reverse the inequality sign. So on this one right here, -10 times y is 60. Well, what is the inverse or the opposite of multiplying by -10? It's dividing by -10. So what do I get? I get y, but I'm going to switch from less than to greater than. 60 divided by -10 is going to give me -6. So there is my solution to that inequality. I'm going to go to -6. I'm going to put an open circle because it's not equal to. All right, and now I'm looking for greater than. So I'm going to go to the right. Okay. All right, 7 is greater than or equal to -t/6. All right, well, the opposite or inverse of dividing by a -6 is multiplying by a -6. All right, so here we go. -6 times 7 is -42. But because we multiplied by a negative, we're going to have to reverse that inequality sign. -42 is less than or equal to, well, a negative times a negative is a positive. All right, but you'll notice the variable is on the right-hand side. In fact, I should have, right at the beginning, if I was doing what I had done previously, I would have flipped it around to start with, but I didn't. I was just solving it, so now I'm going to flip it around. If -42 is less than or equal to t, then that means t is greater than or equal to -42. All right, so I'm going to go to -42. I'm going to put a closed circle because it's got an equal sign on it, and I'm going to go to the right. All right. Again, if I would have flipped it around right at the beginning, I had 7 is greater than or equal to -t/6 or t/6. If you flip that around, t/6, flip that, you get is less than or equal to 7. So the goal is to have the variable on the left-hand side, and then you'll be in good shape. All right. In my next video, I will go through and just do some more examples for you. But that's what we're going to do. We're going to call it a day for this video. Remember, we are using inverse operations. If the inequality involved addition, you subtract. If it involves subtraction, you add. Multiplication, you divide. Division, you multiply. And remember, if you multiply or divide by a negative, you must reverse the inequality sign. All right, until next time, have a great day.